The history of ocean exploration is a fascinating journey that dates back thousands of years. Early civilizations such as the Phoenicians and Polynesians were among the first to venture out into the vast unknown waters. However, it was not until the Age of Discovery in the 15th century that major advancements in ocean exploration were made. Explorers like Christopher Columbus, Ferdinand Magellan, and James Cook set sail to discover new lands and map the world's oceans. Their voyages not only expanded our knowledge of geography, but also paved the way for future explorations. One of the most significant milestones in ocean exploration was the invention of the diving bell in the 16th century, which allowed humans to explore the depths of the ocean for the first time. This led to the discovery of new species and underwater ecosystems that were previously unknown. In the 19th and 20th centuries, advancements in technology such as submarines, underwater cameras, and remotely operated vehicles revolutionized ocean exploration. These innovations enabled scientists to study the ocean floor in detail and uncover the mysteries hidden beneath the waves. Today, ocean exploration continues to be a vital field of research, with expeditions uncovering new species, underwater volcanoes, and ancient shipwrecks. The exploration of the ocean not only helps us understand our planet's history, but also provides valuable insights into the effects of climate change and human activities on marine ecosystems. As we look to the future, it is essential that we continue to explore and protect our oceans for the benefit of future generations. Oceans cover over 70% of the Earth's surface, making them a vital component of our planet's ecosystem. They play a crucial role in regulating the climate by absorbing heat and carbon dioxide from the atmosphere. This helps to stabilize temperatures and maintain a balance in the global climate system. Additionally, oceans are a major source of oxygen production, with marine plants like phytoplankton generating more than half of the world's oxygen supply. Without healthy oceans, life on Earth as we know it would not be sustainable. Oceans also support a diverse range of ecosystems, from coral reefs to deep-sea trenches, providing habitats for countless species of marine life. The biodiversity found in oceans is unparalleled, with millions of species yet to be discovered and studied. Not only do oceans support marine life, but they also play a crucial role in the global economy. The fishing industry, tourism, shipping, and offshore energy production are just a few examples of sectors that rely on the resources and services provided by the oceans. In fact, it is estimated that oceans contribute trillions of dollars to the global economy each year. Oceans also serve as a source of inspiration and wonder, sparking creativity and curiosity in people of all ages. The beauty and mystery of the underwater world have captivated explorers, scientists, artists, and adventurers for centuries. Furthermore, oceans have a significant cultural and spiritual importance to many indigenous communities around the world. They are seen as sacred places that hold deep connections to the past and provide a sense of identity and belonging. Despite their immense value, oceans are facing numerous threats, including pollution, overfishing, climate change, and habitat destruction. It is crucial that we take action to protect and preserve our oceans for future generations. By raising awareness, implementing sustainable practices, and supporting conservation efforts, we can ensure that the importance of oceans is recognized and respected for years to come. The ocean is a vast and dynamic environment that is divided into distinct zones based on factors such as depth, light availability, and temperature. Each zone supports a unique ecosystem with its own set of species and adaptations. Let's explore the different ocean zones and the fascinating ecosystems they contain. Starting from the surface, we have the sunlit zone, also known as the epipelagic zone. This zone extends from the surface down to about 200 meters and receives ample sunlight, allowing photosynthesis to occur. Here you'll find a variety of marine life, including phytoplankton, fish, sea turtles, and dolphins. Moving deeper, we enter the twilight zone, or mesopelagic zone, which ranges from 200 to 1,000 meters deep. This zone is characterized by dim light and a diverse array of bioluminescent creatures, such as lanternfish, vampire squid, and gulper eels. As we descend further into the midnight zone, or bathypelagic zone, which extends from 1,000 to 4,000 meters, sunlight is non-existent and the pressure is immense. Despite the harsh conditions, this zone is home to unique species like anglerfish, giant squid, and deep-sea jellyfish. The abyssal zone, ranging from 4,000 to 6,000 meters, is one of the least explored regions of the ocean. Here, you'll find a variety of bizarre creatures adapted to extreme cold, darkness, and pressure, such as deep-sea octopuses, tripod fish, and Dumbo octopuses. Finally, the Hadal zone, which includes the deepest ocean trenches like the Mariana Trench, reaches depths of over 6,000 meters. Despite the extreme conditions, life thrives in these trenches, with organisms like amphipods, snailfish, and giant tube worms adapted to survive in total darkness and near-freezing temperatures. The interconnectedness of these ocean zones creates a complex and fragile ecosystem that is essential for the health of our planet. Each zone plays a vital role in nutrient cycling, carbon sequestration, and supporting biodiversity. For example, phytoplankton in the sunlit zone produce oxygen through photosynthesis, which is essential for all marine life and helps regulate the Earth's atmosphere. Additionally, deep-sea creatures in the midnight and abyssal zones play a crucial role in recycling nutrients and maintaining the balance of the ocean ecosystem. It is important to understand and protect these diverse ocean zones to ensure the continued health and sustainability of our oceans. By studying and conserving these ecosystems, we can gain valuable insights into the interconnected web of life that exists beneath the waves. The oceans are home to a staggering array of marine species, with an estimated 2 million different organisms inhabiting the underwater world. From microscopic plankton to massive whales, the diversity of marine life is truly remarkable. Let's delve into some fascinating details about marine species diversity. One of the most biodiverse marine habitats is the coral reef, which supports a vast array of species in a relatively small area. Coral reefs are home to over 25% of all marine species, despite covering less than 1% of the ocean floor. These vibrant ecosystems are teeming with life, including colorful fish, sea turtles, sharks, and countless invertebrates. Another group of marine species known for their diversity are the cephalopods, which include octopuses, squids, and cuttlefish. These intelligent creatures exhibit a wide range of adaptations and behaviors, from the camouflage abilities of the octopus to the jet propulsion of the squid. Some cephalopods can even change color and texture to blend in with their surroundings or communicate with other individuals. Moving on to the open ocean, pelagic species like tuna, dolphins, and billfish roam the vast expanse of water, utilizing different strategies for survival. Tuna, for example, are powerful swimmers capable of crossing entire oceans in search of food, while dolphins rely on echolocation to navigate and communicate in the open sea. In the deep-sea environment, where sunlight does not penetrate, unique species have evolved to thrive in extreme conditions. Deep-sea anglerfish, for instance, use bioluminescent lures to attract prey in the darkness, while gulper eels possess expandable jaws to swallow large meals in the deep ocean trenches. The diversity of marine species extends to the smallest organisms as well, with phytoplankton and zooplankton forming the base of the marine food chain. These microscopic organisms play a crucial role in nutrient cycling and oxygen production, supporting the entire marine ecosystem. Overall, the incredible diversity of marine species highlights the complexity and interconnectedness of ocean life, underscoring the importance of conservation efforts to protect and preserve the rich biodiversity of our oceans. Marine life faces a myriad of threats in today's world, many of which are directly linked to human activities. One of the most pressing issues is plastic pollution, with millions of tons of plastic waste entering the oceans each year. This plastic debris poses a significant danger to marine animals, who can become entangled in it or mistake it for food. In fact, studies have shown that over 8 million tons of plastic end up in the ocean annually, impacting over 600 species. Another major threat to marine life is overfishing, which has led to the depletion of fish stocks and disrupted entire marine ecosystems. Unsustainable fishing practices, such as bottom trawling and bycatch, contribute to the decline of species like sharks, tuna, and sea turtles. Climate change is also taking a toll on marine life, causing ocean temperatures to rise and leading to coral bleaching events. Coral reefs, often referred to as the rainforests of the sea, are particularly vulnerable to warming waters, resulting in widespread coral mortality. Additionally, ocean acidification, a consequence of increased carbon dioxide absorption by the oceans, poses a threat to shell-forming organisms like oysters and corals. These are just a few examples of the many threats facing marine life today, highlighting the urgent need for conservation efforts and sustainable practices to protect our oceans and the diverse species that call them home. Conservation efforts play a crucial role in protecting marine ecosystems and species from the threats they face. One notable conservation success story is the recovery of humpback whale populations. Through international cooperation and the implementation of protective measures, humpback whales have rebounded from the brink of extinction. Marine Protected Areas, MPAs, are another effective conservation tool, providing safe havens for marine life to thrive. These designated areas help preserve biodiversity, restore fish stocks, and safeguard critical habitats. Sustainable fishing practices are essential for maintaining healthy marine ecosystems. By implementing quotas, gear restrictions, and monitoring programs, fisheries can reduce overfishing and minimize bycatch. Community-based conservation initiatives empower local communities to take an active role in protecting their marine resources. These grassroots efforts often lead to innovative solutions and foster a sense of stewardship among community members. Public awareness campaigns and education programs are vital for engaging individuals in conservation efforts. By raising awareness about the importance of oceans and the threats they face, we can inspire action and promote sustainable behaviors. Collaborative research projects bring together scientists, policymakers, and stakeholders to develop science-based conservation strategies. By sharing knowledge and expertise, these partnerships drive conservation efforts forward and contribute to the long-term health of our oceans. Technological advances in ocean exploration have revolutionized our understanding of the underwater world, allowing us to delve deeper into the ocean's mysteries than ever before. One of the most significant innovations in ocean exploration is the development of remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs. These robotic devices can withstand extreme pressures and temperatures, enabling scientists to explore deep-sea environments that were once inaccessible. ROVs equipped with high-definition cameras and sampling tools have captured stunning footage of deep-sea creatures and hydrothermal vents, providing valuable insights into these unique ecosystems. AUVs, on the other hand, are programmed to navigate autonomously and collect data on ocean currents, water chemistry, and marine life. Another game-changing technology in ocean exploration is multi-beam sonar mapping, which uses sound waves to create detailed 3D maps of the ocean floor. This mapping technique has revealed previously unknown seamounts, underwater volcanoes, and ancient shipwrecks, shedding light on the geological history of the ocean. Satellite technology has also played a crucial role in ocean exploration, allowing scientists to monitor ocean temperature, salinity, and sea level from space. Satellite data helps track ocean currents, predict weather patterns, and study the impact of climate change on marine ecosystems. Underwater drones, or gliders, are another innovative tool used in ocean exploration. These autonomous vehicles can travel long distances underwater, collecting data on temperature, salinity, and marine life. By deploying a network of underwater drones, scientists can monitor ocean conditions in real time and study phenomena like ocean acidification and coral bleaching. The development of advanced imaging technologies, such as 3D mapping and laser scanning, has revolutionized our ability to study underwater habitats in unprecedented detail. These imaging techniques provide scientists with high-resolution images of coral reefs, underwater caves, and deep-sea ecosystems, allowing for accurate habitat assessments and species inventories. Overall, technological advances in ocean exploration have opened up new frontiers of discovery and transformed our understanding of the ocean's vast and diverse ecosystems. The future of ocean exploration holds exciting possibilities with the continued advancement of technology. Autonomous underwater vehicles, AUVs, equipped with artificial intelligence, are set to revolutionize deep-sea exploration, allowing for more efficient data collection and analysis. Miniaturized sensors and cameras will enable researchers to study marine life in unprecedented detail, unlocking new insights into underwater ecosystems. Furthermore, the development of underwater habitats and submersibles will provide scientists with the opportunity to live and work beneath the waves for extended periods, opening up new frontiers for research. With ongoing efforts to map the unexplored depths of the ocean and harness the power of big data analytics, the future of ocean exploration promises to unveil even more secrets of the underwater world.